Alright, let's talk about something that sounds super complicated, but is actually a concept you deal with every day. Transactions. Imagine you're buying a book online. Your payment has to be approved. The money has to move from your account to the bookstore's account. The store's inventory needs to be updated to show one less book. A shipping order needs to be created. A transaction is a group of these individual steps that must all succeed together as a single indivisible unit of work. If even one of those steps fails, say, your payment is declined, then the whole thing should be undone. You don't get the book, you also don't get charged, and the inventory count doesn't change. It's an all or nothing deal. This all or nothing principle is super important in software, especially when we're dealing with data. It's what keeps our digital world from descending into absolute chaos. Now that we understand what transactions are and why they're so critical, let's talk about how we actually implement them in our code. Traditionally, developers had to manage transactions programmatically. You'd write explicit code to start a transaction, then a try-catch finally block to handle the logic. Inside the try block, you'd perform your database operations. If everything went well, you'd explicitly commit the transaction. If any exception occurred, the catch block would roll back the transaction. This approach works, but it clutters your business logic with a lot of boilerplate code that's all about managing the transaction itself, not about what the transaction is actually doing. This is where the Spring framework comes in with a truly elegant solution: declarative transactions. The word declarative is key here. Instead of telling the computer how to do something step by step, the imperative way, you simply declare what you want to happen. With Spring, you don't write the code to begin, commit, or roll back a transaction. Instead, you just mark a method, say, transfer money, with a special instruction. You declare your intent, and Spring handles all the messy behind-the-scenes work for you. It's like ordering a pizza instead of making one from scratch. You just state your desire for a pepperoni pizza, and the pizzeria handles the dough, and the pizzeria handles the sauce, and the pizzeria handles the baking. So, how does Spring pull off this magic trick? It uses a powerful concept called aspect-oriented programming, or AOP. Think of AOP as a way to add extra behavior to your code without changing the code itself. When you tell Spring that a method is transactional, Spring creates a proxy object that wraps around your actual object. This proxy acts like a security guard standing in front of your method. When your code calls the transfer money method, it's actually calling the proxy first. The proxy starts a transaction, then calls your real method to do the actual work. Once your method is finished, the proxy takes over again to either commit the transaction if everything was successful, or roll it back if an error was thrown. The beauty of this declarative approach is the clean separation of concerns. Your business logic, the code that defines how to transfer money, is completely separate from the transactional logic. Your transfer money method only contains the steps for moving funds between accounts. It doesn't know or care about the underlying mechanics of starting or stopping a transaction. This makes your code infinitely cleaner, easier to read, and much simpler to maintain. You can focus on writing the core logic of your application, trusting that Spring's well-tested transaction management system is reliably handling data integrity for you. It's a powerful abstraction that lets you work at a higher, more conceptual level. The bookstore would have your money, but its system would still think the book is on the shelf. You'd be out of pocket with no book on the way, and the store's records would be a complete mess. This kind of data inconsistency can lead to all sorts of problems: angry customers, serious financial errors. Transactions prevent this by ensuring that the entire group of operations is treated as a single, logical block that either completely succeeds or completely fails, leaving no messy partial changes behind. So, at its core, a transaction is a safety net for our code. It allows us to perform complex operations, transferring money, booking a flight, processing an order, with confidence. We can be sure that the data will remain in a consistent and reliable state, no matter what happens. It's the foundational mechanism that allows developers to build robust and trustworthy applications that people can depend on. So, you're sold on the idea of letting Spring handle your transactions. Great! But how do you actually tell Spring to do it? The most common and modern way is by using annotations. Annotations are like little metadata tags that you add to your code to give instructions to Spring. The main star of the show here is the transactional annotation. By simply placing transactional above a method or above an entire class, you declare your transactional requirements. It's a straightforward signal to Spring's AOP proxy. Wrap this piece of code in a transaction. It's that simple. Let's make this concrete, with a step-by-step example. Imagine we're building a simple banking application. The most classic transaction example is transferring money from one account to another. This operation involves two distinct steps: debiting the money from the sender's account and crediting the money to the receiver's account. Both of these steps must succeed. If we debit the sender but the system crashes before we can credit the receiver, that money has just vanished into thin air. This is exactly the kind of disaster that transactions are designed to prevent. So, let's see how we'd implement this using Spring. First, we'd have a service class, let's call it Bank Service. This class would be responsible for the business logic of the transfer. Inside this class, we would define a public method, something like public void transfer, with parameters for the sender's account ID, receiver's account ID, and the amount. This method will contain the core logic for the transfer. It will first call a repository or a data access object to retrieve the sender's account check if they have sufficient funds, and then update their balance. After that, it will retrieve the receiver's account and update their balance. Notice, this is all just plain Java code describing the steps of the transfer. Now, here comes the Spring magic. To make this entire operation transactional, we simply add the transactional annotation directly above the transfer method signature. That's it. Just one line of code, transactional. By adding this annotation, we are telling Spring that the entire body of the transfer method should be executed within a single atomic transaction. Spring's AOP proxy will intercept the call to this method, begin a transaction with the database before the first line of your method executes, and then watch for what happens next. The code inside your method doesn't need to know anything about this. Let's trace the flow. When transfer is called, the Spring proxy starts a transaction. Your code runs, it debits the from account ID. Let's say that works. Then it attempts to credit the to account ID. But what if, for some reason, the to account ID doesn't exist, and your code throws an exception? Because an exception was thrown, the Spring proxy will catch it. Instead of committing the transaction, it will automatically issue a rollback command to the database. The initial debit operation that had already happened will be completely undone. The sender's account balance will be restored to what it was before the transfer was attempted. So, let's wrap this all up. We've seen that transactions are the bedrock of reliable data management, ensuring our operations follow the all-or-nothing principle of atomicity. They are the safety protocol that prevents our databases from becoming a corrupted, inconsistent mess. We then explored the two main ways of handling them. The old-school programmatic way, which involves writing a lot of manual try-catch, commit rollback code, and the much cleaner, more modern declarative way offered by the Spring framework. The programmatic approach mixes our business logic with technical transaction management code, making it harder to read and maintain. It forces you to focus on the how of the transaction. Spring's Declarative Transactions, powered by aspect-oriented programming, flip this on its head. By using a simple annotation like transactional, we declare our intent for a method to be transactional, and we let the framework handle the implementation details. This creates a beautiful separation of concerns. Our service layer methods can focus purely on implementing business rules, the what, while Spring's proxy mechanism transparently manages the transactional boundaries, the how. This leads to code that is significantly cleaner, more readable, and less prone to errors, because the complex, repetitive logic of transaction management is handled by a robust and well-tested framework. The setup, as we saw, is remarkably straightforward, especially in a modern Spring Boot application. With Enable Transaction Management, to turn on the feature and the automatic configuration of a platform transaction manager, all that's left is to sprinkle the transactional annotation where it's needed. This low barrier to entry means that developers can easily and consistently apply strong data integrity rules across their entire application without writing mountains of boilerplate code.